Hello, AngularConnect. How is everyone doing today? My name is Jeff, as I was introed. If you've ever heard of that Jeff guy, that Angular Jeff guy, that's me. I'm here today to start off telling you a story about 5 years ago, about when I met up with my good friend Christian, and over a couple of beers, we decided to start a company called Get Human, a website that helps people with customer service problems. And for the first year or two, it was great. It was very simple. It was just Christian and I as the only developers working on this growing code base, and we knew every line of code. I was totally in sync with him and he was with me because there's only the two of us, so it was very simple. And over time, Get Human grew, and we eventually, it grew bigger. We actually got up to about 5 million people a month coming to Get Human with customer service problems and helping them, and it was great. And so Christian and I went out and raised some money, and we hired a bunch of more developers to work on even more code. So everybody was working on different applications, even more than what Christian and I were working on originally. You know, new website, new native app, an AI robot, a bunch of different things. And all these different pieces had a lot of pieces of shared code. So, state of where we were, there was shared code. We had a team of people. It wasn't just the two of us anymore. There was a lot of developers. We were making a lot of changes. Every single developer on our team was trying to push code to production every single day. So it was very rapid development, a lot of changes going on. And because we were a startup, we cared about the individual productivity of each developer. You know, we didn't have a lot of money. So it really maximizing the output of every single developer and us as a team as a whole was super, super important. And that's where we ran into challenges, because there were a number of things that started to happen when we had all these team members trying to change code in the same code base at the same time. For example, there were times where two team members were working on different pieces but had a piece of shared code, and one developer would end up blocking the other developer from deploying production. So it would delay how rapid we were changing things, and that would cause us problems. Or another developer would change a shared piece of code for their app, but then inadvertently break somebody else's app. And I know that nearly every one of you in this room has had a problem related to development process inefficiencies. For example, how many people, as a sign of hands, have made a 1 or 2 line code change that has taken a month or more to get into production? So, almost everyone. And that's sad. That's extremely frustrating because it doesn't have to be that way. It shouldn't be that way, right? We're like stepping on our own 2 feet. And for those few of you who did not raise your hand, I want to give you a forewarning because winter is coming. This is something that affects all of us. So I write in much more depth about all these types of problems that occur in a blog post I published about a month ago. Definitely check it out. It's very cathartic, especially because I know a lot of us have experienced these same types of things. But today, I don't necessarily want to dwell on the problems as much as talk about solutions. And when we talk about solutions, it's good to look at what other people are doing. Because this is obviously a universal thing, trying to create efficiency within our development organizations and maximize how we best utilize our code bases is something that everybody wrestles with. And some people are doing a good job of it. So I went out and talked to a lot of my friends that work at some of these companies that are very well known for good development processes, having big, big teams that keep high levels of productivity. And so the interesting thing was they're all kind of slightly different. At Amazon, I talked to Dave Smith, who is a friend of the Angular community. He's the host of the Soft Skills podcast. He currently is on the Alexa team at Amazon. And he was telling me about how Amazon focuses mostly on microservices and micro-repos, that everything there is small and componentized. And so for one relatively minor web application, you might have 5 or 6 different micro-repos that constitute that. And the way they manage some of the overhead of that is a huge set of internal tools that make it easier for developers. However, more recently, they've been pushing the internal teams to utilize some of the stuff that they have within AWS. So I don't know if you guys have noticed, because I actually didn't before I started looking into this, but AWS actually has a pretty deep set of developer tools called code build, code deploy, code pipeline, these things that help with building microservices. So this is, there's a little bit of a lock-in there that it's only when you're kind of working in the AWS world, but it's still very interesting to look at when you're talking about these types of things. Netflix is very similar in terms of they believe in microservices and micro-repos as well. They have something called freedom and responsibility that's part of their culture, that most people work on the paved road, a very common way of doing things within the organization, but you can do whatever you want. If you want to use a monorepo, if you want to use a completely different technology than anybody else is using, that's totally fine. But because you're not using the paved road, you have the responsibility to take ownership over that. So it's just a different way of thinking, but it's still interesting. They have a lot of internal tooling that they use, but they also have a lot of open source tools as well. There's a blog post, How We Build Code at Netflix, which really gets into the depth of it, but they built a number of tools like Spinnaker that they've open sourced. So some of this, at least, not all of it, that they use internally, you can actually utilize as well. Much different than Amazon and Netflix, Facebook puts all of their code into one big Mercurial monorepo. And one of the biggest challenges with all your code in one code repository is build and deployment processes, because normal build tools do not work in that environment when you have a huge repo like that. So Facebook built their own build mechanism and open sourced it that's called Buck. Okay. But that's not the most amazing part of what Facebook does, actually, is their deployment mechanism. They have this amazing incremental deployment mechanism that allows anybody who pushes to master and gets into the deploy pipeline to slowly deploy out to bigger and bigger audiences, starting with their internal team at Facebook, and then a small audience externally, and then bigger and bigger and bigger until it reaches the billions of people that Facebook has worldwide. So developers feel very safe deploying every day tons of code because they know if there's any issues, it gets kicked back to them right away. Now, in terms of what we're talking about today, the only problem is that that system is totally proprietary for Facebook. So there's some stuff like Buck and Mercurial you can use, but the deployment mechanism, we can't really do anything like that, so it doesn't help us as much. Google, similar to Facebook, uses a monorepo. They use Piper instead of Mercurial. They have their own build system. They use, internally it's called Blaze, but the open source version externally is called Bazel, which you guys may have heard about in other talks this conference. And a lot of what they do is outlined in Alex Eagle's recent couple of blog posts that he put out there, which are really good, talking about what Google does internally, as well as what the Angular team has done and what they're starting to promote and talk about. And I'm really excited that it worked out that Rado is speaking right after this talk in, I think, the other room about the specifics of that, exactly how Google uses Bazel, uses the monorepos. So for the low-level details of that, which I'm not going to get into in this talk, definitely check that one out. So what can we learn from this? As you can kind of gather, even though there is a lot of efficiency within these organizations, they each do things very, very differently. for one thing, Amazon and Netflix are way on this side of the scale, where they believe in micro repos and small, everything's small, whereas Google and Facebook are on the monorepo side and everything's big, and there's huge differences between those two. But then even going beyond that, the tool chain for each of these companies is different. They do use open source products, but they're all different. And in addition to that, there's a set of internal tools that you and I can't even access. So even though it's really interesting to look through this and understand what everybody is doing, it still leaves us in this state like, okay, well, what can we take as actionable from that into our lives today? And so that's what I wanted to focus on for this last part here in terms of specifically Angular. And when I think about applying, seeing what's done at these other organizations and in a simple way that we can apply it to Angular, I kind of break up the development of Angular apps into 3 different stages. So stage 1 is where most of us are at today, where we're using Angular CLI and we're creating one singular app. And for the most part, this is a good place to be. It's not, shouldn't add extra complexity if you don't need it. You've heard of premature optimization. You shouldn't do premature complexity or premature organization. Stay here for as long as you can, but where you need to do something more is when you start working on multiple applications within your organization that have some level of shared code. So you need something more than this. And for that, I actually was working on this talk for a couple months now, and I reached out to my good friend, the other Jeff. So I said, I'm Jeff, this is the other Jeff. And the other Jeff was telling me, oh, it's great that you're talking about this because my team at Neural has been working on a solution for this same type of problem that we see people have. And it's called NX extensions. Specifically for what we're talking about here, there is the NX workspace, which basically is a structure within your Angular application for organizing multiple applications and multiple libraries in a very simple way. Like I'd actually started thinking about this problem months ago, and this is much simpler than some of the other stuff that I came up with for this level. Now this isn't solve everything, but if you can work within this structure, you should definitely do it because it keeps things simple while still allowing you the power of sharing code among multiple applications. But it's not good enough in some cases. Specifically, when we start thinking about moving from this stage to the next bigger stage is when 1 or 2 things happen. The first is you have different technologies that start to be involved. So it's not just Angular web apps, but you're using a native script app, which doesn't necessarily fit into that structure, or you want to include your GraphQL server as part of what you're doing, you're organizing for your team, or Java or .NET or some other technology completely different. And so whenever you're using another technology, or when you care, there's issues with the throughput of the team. So in some cases, where, like I mentioned earlier, where the team is kind of stepping on each other, it helps to create swim lanes where the team doesn't have to worry about what somebody else is doing and they can kind of work in parallel much better. So when you start, and this, you should only care about when it starts to happen, okay? So like we were experiencing this pain specifically, and I'm sure that a lot of you guys have seen that at certain points in your career as well. So when either these 2 happen, you think about a different type of stage, and that's where this last one, multiple products, come in. And there's 2 parts to this stage of multiple products. So one is product monorepos. So having multiple monorepos within your organization based off a product, which I'm going to talk about in a second. And then the other is utility microrepos, or for short, prepos and mepos. No? Okay. Product monorepos and utility microrepos. Okay, so let me first go over utility microrepos because they're much easier and easier to define. And for this, I'll get the help of my good friend, Dr. Gleb Bamatov, who is the master of micro-repos. Dr. Gleb is a friend of the Angular community as well. He's done a ton of conference talks at Angular conferences, and if he could, he would do everything in his entire life in micro-repo, a series of micro-repos. So Gleb's rules involve, number one, that it's got to be small, that your micro-repo should just have a singular purpose. Number two, it should be testable. Specifically, in the ideal case, 100% test coverage and unit testable. And believe me when I say I'm not a fanatic about testing, and I think a lot of times it's more trouble than it's worth, especially in more complex libraries. But that's sort of the point, that like if you can't get this small library to be 100% test coverage, that in itself is a smell that perhaps it's not a suitable candidate for this. And then the other thing is that it's stable, that it doesn't help anything if you're changing this code all the time, because then you have to bubble that change up to all your upstream dependencies constantly. So it should be something that you just kind of put out there and you use, but it's stable. You don't have to change it. And then the last thing is that it's somewhat isolated. That this was actually a mistake that we made at first, where we created these smaller libraries, but there was kind of this complex hierarchy. And whenever you have a multi-level hierarchy of dependencies, even if each independent item is small, you create additional complexity, because then you have to worry about managing all the interactions and bubbling up changes through the hierarchy. So the ideal case with these utility micro-repos is to make it flat. Try to avoid any downstream dependencies at all, if possible. All right, so a little bit more complex is the product monorepos. And the characteristics of this, one of the first ones, which is a little bit subjective, is that they should be split up by quote-unquote team. And this doesn't have to be physical team. It can be, really the whole purpose is creating those swim lanes that I talked about. So it really comes down to thinking about your organization and thinking about how you want to organize how your company does work. And a lot of this comes naturally to some degree, but what I would say is start off with one. You could start off with one monorepo, but then as you start to see where people are running into issues, where there might be opportunities, you can start to split away into multiple monorepos, which is sort of what we ended up doing, and I'll show an example of that in a minute. They should be self-contained. So for each one, so the litmus test here is that as part of a team that's working on this one particular product, 70 to 80% of the changes that I make should just be contained within that repo. The moment that you see yourself making changes where you have to coordinate between multiple repos is that sort of smell that perhaps you don't have the abstractions set correctly. And then finally, this is a tough one for me because it's a complete 180 degrees from where I was at about 4 years ago. I used to be the biggest proponent of finding any level of duplicated code across your entire stack and refactoring it into a shared piece of code. What I've come to realize more over the past 4 years is that anytime you do that, you create a dependency, and a dependency is a contract that has a cost. A cost in terms of making sure when you change that shared code, you have to test everything else, all the upstream dependencies. You have to communicate to all of the different pieces. So in terms of what we're talking about here, a much better strategy is PRY, please repeat yourself. Start off within your product monorepo of just putting code there, even if you know that somewhere else in your organization, technically there is a piece of code that does something similar, that's fine. Copy it, duplicate it locally, just to get it working and have speed of delivery. And then later, after the code matures and stabilizes, you can start to refactor it out into something else when you know that it is a good abstraction and you feel more confident. So let's see a quick example of this, and I'll use my own work as the model here. So at GetHuman, we actually have 3 product monorepos, one for the GetHuman website, one for a new product called Swish, a budgeting app that we just came out with last month. And then actually our core API is also a separate product, which I'll talk about in a second. And then we have dozens of different micro-repos for different small pieces of functionality, some which are publicly exposed, some are private. So let's look deeper into Swish. So with Swish, and this doesn't contain everything, I sort of boiled it down just to make it a little simpler. But we have a number of different packages within the product monorepo. So we have the website, which is an Angular app, a native app, which is a native script app. We have a state package, which is basically our shared NGRX state that is shared between our web and native. We have an API, which I'll mention in a second, and worker processes that do batch-related stuff. So the interesting thing with this is that the API is a good example of where there is some level of trying to work in this self-contained environment. Because, as I mentioned, we do have this other core API, but the difference is that the core API is a monorepo that we treat as a product. And by that I mean that it's not built specifically to service Swish or anything else. We build it more generically as if we were going to, the sort of way, a mental model is to think about it as if you were exposing it externally to anyone. And so you build it more generic and you build it in a more robust way that is sort of self-managed and isn't going to change for every single client that comes on. And if there is a specific piece of functionality needed for a particular client, in this case Swish, then it's in this wrapper API on top of it that is local, because that's where we're iterating and doing all of the local changes for Swish. And there's other dependencies too, like I mentioned, that from the micro-repo standpoint, there's various packages within the monorepo that reference those. But again, those don't change. The micro-repos are very stable and just are there. And the one piece of technology that I didn't mention that sort of ties this together is, we currently use is Lerna. So I'm not sure if anyone uses this now, but it is a great way to manage stuff in a small monorepo. I stress small because, relatively speaking, because there is a sort of point where something more like a Bazel is needed because it gets to be too big. But because the product repos are single team, and because they are relatively small, because once they get to be too big, you actually usually end up splitting into multiple product monorepos, Lerna is a good place to start. It's much easier to learn, and it's much easier to implement than Bazel. So you can use that, see how it works. It doesn't have some of the capabilities of Bazel, but start there, and then if you run into problems, then you can implement Bazel on top of that in your monorepo later. Now, there's a lot of stuff to talk about today, a lot of other details that I haven't been able to get into. So I'm going to actually spend some time over the course of the next couple months putting some of the lower level subtleties into a deep dive on my blog. So follow me on Medium and on Twitter to kind of get some more information about this. Also, in the slides from my presentation, I have a link to. Right after this talk, I mean, you should probably go to see Rado, but if you did have questions for me, I'm also going to be in office hours right afterwards. And a whole bunch of people that helped me with this talk, just giving me advice and talking about what they do at work. So I really appreciate that. And that's it. Thanks a lot.